Welcome back. In the last video, we saw some example classification inputs and outputs. The main takeaway that the inputs to a classification model, particularly a neural network, want to be some form of numerical representation, and the outputs are often some form of prediction probability. So let's discuss the typical architecture of a classification model, and hey, this is just going to be text on a page, but we're going to be building a fair few of these. So we've got some hyperparameters over here. We've got binary classification, and we've got multi-class classification. Now, there are some similarities between the two in terms of what problem we're working with, but there also are some differences here. And by the way, this has all come from, if we go to the book version of the course, we've got what is a classification problem, and we've got architecture of a classification neural network. So all of this text is available at learnpytorch.io and in section 2. So we come back. So the input layer shape, which is typically decided by the parameter in features, as you can see here, is the same of number of features. So if we were working on a problem such as we wanted to predict whether someone had heart disease or not, we might have 5 input features, such as one for age, a number for age, it might be, in my case, 28, sex, could be male, height, 180 centimeters. If I've been growing overnight, it's really closer to 177. Weight, well, it depends on how much I've eaten, but it's around about 75 kilos. And smoking status, which is 0. So it could be 0 or 1, because remember, we want numerical representation. So for sex, it could be 0 for males, 1 for female, height could be its number, weight could be its number as well. All of these numbers. Could be more, could be less as well. So this is really flexible, and it's a hyperparameter. Why? Because we decide the values for each of these. So in the case of our image prediction problem, we could have in features equals 3 for number of color channels. And then we go hidden layers. So there's the blue circle here. I forgot that this was all timed and colorful. But let's just discuss hidden layers. Each of these is a layer, nn.linear, nn.linear, nn.relu, nn.linear. So that's the kind of the syntax you'll see in PyTorch for a layer is nn.something. Now there are many different types of layers in this in PyTorch. If we go torch nn, basically everything in here is a layer in a neural network. And then if we look up what a neural network looks like, neural network, recall that all of these are different layers of some kind of mathematical operation. Input layer, hidden layer, you could have as many hidden layers as you want. Do we have ResNet architecture? The ResNet architecture, some of them have 50 layers. Look at this. Each one of these is a layer. And this is only the 34 layer version. I mean, there's ResNet 152, which is 152 layers. We're not at that yet, but we're working up the tools to get to that stage. Let's come back to here. The neurons per hidden layer. So we've got these out features, the green circle, the green square. Now this is, if we go back to our neural network picture, this is these. Each one of these little things is a neuron, some sort of parameter. So if we had 100, what would that look like? Well, we'd have a fairly big graphic. So this is why I like to teach with code, because you could customize this as flexible as you want. So behind the scenes, PyTorch is going to create 100 of these little circles for us. And within each circle is what? Some sort of mathematical operation. So if we come back, what do we got next? Output layer shape. So this is how many output features we have. So in the case of binary classification is one class or the other. We're going to see this later on. Multi-class classification is you might have 3 output features, 1 per class, e.g. 1 for food, person, or dog if you're building a food, person, or dog image classification model. Hidden layer activation, which is, we haven't seen these yet, ReLU, which is a rectified linear unit, but can be many others because PyTorch, of course, has what? Has a lot of non-linear activations. We're going to see this later on. Remember, I'm kind of planting the seed here. We've seen what a linear line is, but I want you to imagine what a non-linear line is. It's going to be a bit of a superpower for our classification problem. What else do we have? Output activation. We haven't got that here, but we'll also see this later on, which could be sigmoid for, well, which is generally sigmoid for binary classification, but softmax for multi-class classification. A lot of these things are just names on a page. We haven't seen them yet. I like to teach them as we see them, but this is just a general overview of what we're going to cover. Loss function. What loss function, or what does a loss function do? It measures how wrong our model's predictions are compared to what the ideal predictions are. So for binary classification, we might use binary cross-entropy loss in PyTorch, and for multi-class classification, we might just use cross-entropy rather than binary cross-entropy. Get it? Binary classification, binary cross-entropy. And then optimizer, SGD, stochastic gradient descent. We've seen that one before. Another common option is the Atom optimizer. And of course, the torch.optim package has plenty more options. So this is an example multi-class classification problem, this network here. Why is that? And we haven't actually seen nn.sequential, but as you could imagine, sequential stands for it just goes through each of these steps. So multi-class classification because it has 3 output features, more than one thing or another. So 3 for food, person, or dog. But going back to our food vision problem, we could have the input as sushi, steak, or pizza. So we've got 3 output features, which would be 1 prediction probability per class of image. We have 3 classes, sushi, steak, or pizza. Now, I think we've done enough talking here and enough just pointing to text on slides. How about in the next video, let's code. I'll see you in Google Colab.